topic is, how to detect the frauds that are happening around in pretty much all over the world, and then utilize big data to make sure that we catch the fraud even before it happens. Prevention. If prevention is not possible, how fast we can detect before the money actually changes too many hands. That's the topic today, and let's spend little time on what happens in a bank, and thereafter we'll move on. Well, what's are all the common frauds that take place, especially phishing, and then farming, and then lot of social networking advertisements on which when you click, it ends up taking you to a site, and then you register it. Finally, you get malware into your machines, and then that leads to fraud. How? Well, the fraudster is going to capture all your information, and then he logs in on behalf of you, and then he does the wire transfers or whatever from your account to his account. And then bank's supposed to catch it, and how the whole process takes place. Prevention is the most important thing, and if that cannot happen, then what's the next step? Detection. Okay, just go through the slide. I'll give you a couple of seconds. Well, our target is going to be big data. How the big data is useful in preventing frauds or detecting frauds. Okay, and to come out with the big data, yes, we use different technologies, and then moreover in the coming slides I need not tell you, he is obviously stealing money from an account, and how that's going to happen. Fraud obviously an unfair thing, and then he is coming out with his own ideas, technologies to log in as yourself, and then stealing your account. Lot of different frauds can happen. Electronic banking, and I can spend whole day on the total star thing, but please take a moment, have a look at it. We'll discuss in detail later. Okay. What do we do about this proactiveness? Even before that happens, how we are going to catch it, and what are all the various tools we can use? I'm sure every bank understands the importance of this and puts things in place to catch the fraud even before it happens. So we'll see. Well, first of all, bank has to understand the customer's behavior. What times he is logging in, and then how much amount of transaction he is usually going for, things like that. And once they get the details from the account thing, and whenever they observe any anomaly thing, then immediately they can either prevent the transaction or try to reach the customer, find out whether he is the one actually doing the transaction, and then let the transaction go, or whatever they have to decide. So business tools, well, this is where the bank has to really understand what type of things they can logically implement. It's kind of an engine, and which comes out with certain rules to either to let the transaction continue or not. Well, a customer may be having multiple credit cards, or multiple ATM card, debit card, whatever it is. All these are different things. Cross-channel support is very important. So the software that you are going to consider must support the cross-channel activity. So eventually, a simple example I can quote you. let's say I am in New York, and then the very next day I landed up in Los Angeles and swiped my credit card to check in into a hotel. And then bank has seen this transaction from Los Angeles, in a hotel, coming from a hotel, that's a merchant. And then in an hour's time, I landed up in an ATM and tried to withdraw some cash, maybe $200 cash out of ATM box. So as long as bank has enough intelligence, they can correlate this credit card transaction from a bank and then debit card transaction from the ATM, and can sense that yes, this is a genuine thing and our own customer is doing, because the fraudster cannot obviously steal both the cards at the same time, and they can come out with a scoring on the transaction, and they can decide whether it has to be accepted or not. Lot of softwares, the prevention softwares, I'll give you the names of a few important in a moment, but these software companies, what they do, they get the fraudsters activities and come out with a database that can be shared with the bank, and then that is called external data, and then find out whether this particular account holder is a genuine holder or not, genuine card holder or not. So they're supposed to work with the external data. And risk scoring, again the same thing. Each fraudulent transaction has to go through a risk scoring process, and finally yes, they have the ability to detect whether it is a genuine one or not. Scoring is very important, and these softwares which sit in between the transaction and the bank server, they sit in the middle of it, and then they have that enough intelligence, whether to allow the transaction or not. Alerts. Well, the moment any transaction is found to be non-genuine, immediately yes, an alert has to be passed not only to the customer but also to the fraud agent of the bank, so that some action can be taken on the so alerts are very important. The alert can be through email or SMS on your cell phone or whatever. So usually I'm sure even here many banks are following the same thing. The moment you swipe your card, you get a message stating that so and so amount has been withdrawn using ATM center at so and so place. False positive. This is a very important aspect. I'm guessing that it could be a fraud, but again the moment I messaged customer that there is a transaction, should I allow it or not, the customer may get annoyed, because it's a genuine transaction, he want that to pass through. He doesn't have time to wait at the point of sale for more than a couple of seconds. And false positives must be reduced by this third party software whichever you're considering, so that the customer satisfaction can be improved. Yes, there could be some fraudulent transactions, but if each of the transaction, if you start doubting, then customers will be annoyed. And I have to understand the pattern. What do you mean by pattern? Let's say a guy who does usually transactions not more than 5 or 10 in a month, but all of a sudden there are more transactions coming in, and then the bank can start suspecting what is going on. And that's a pattern. You have to understand his, based on the past behavior of the card holder, yes, you can come out with some ideas. Bottom line, the reporting. If the whole thing is put into place, but the reporting is not happening, again it doesn't make any sense. So whatever the software that you use, which is like in between the customer and the banking software, the middle layer must have enough capabilities to come out with the reports, so that our managers can come out with the correct decisions, and how to improve the system, how to modify the rules engine, what we talked about in point number 2. So for each case it is like a lesson, new lesson for fraud agents. The moment they come out with another fraud thing, they'll have well, in this diagram I just want you to understand, we have several types of users coming in and then doing the transactions. As you can observe, so these are the servers which are taking care of all the incoming transactions, which could be from your ATMs or point of sale, whatever. and then we have a policy in place. What type of, based on the rules that you define, we have a policy, and assume that a particular policy is not yet implemented, then yes, maybe that goes through all right and we never could catch the fraud, and that happened. Then what happens? Well, lot of analysis has to be done. First we need to collect the data and put it through the analysis, and finally, we need to go through all this reporting, collection, compliances and everything. So this picture I am going to use 3-4 different times, because as is my previous picture mentioned you, yep, you need to be proactive, and in case if you could not catch it, then you have to be reactive, and bottom line, some kind of action needs to be taken. That could be legal action or whatever, compliances, all that stuff. So the same diagram, we'll use it for different actions: proactive, reactive actions, preventing, detecting, and then well, we are trying to prevent based on the scoring. How do we come out with a score? Well, based on the credentials of the user, whether he is able to log in for the first time, or so many factors that we take into consideration. Somehow the transaction went through, and then the fraudster finally took us for a ride, then it becomes into. But no bank likes to receive a call from the customer after receiving the monthly statement and say that, by the way, I see a transaction in my account which I never did. Then that means bank failed to catch the transaction as a fraudulent one. Sometimes it may still happen, but we supposed to have enough intelligence to get it even before customer realizes it. And some banks are afraid to let customer know that, by the way, there is some fraudulent transaction. Immediately, yes, customer may feel that, is this bank very secured or not? So no, that is actually a wrong thinking. The customer will welcome, because you caught it even before that could happen. So bankers should take it in a positive way. Customers must be notified either by email, SMS, phone call, whatever. And then in case if fraud anywhere takes place, yes, actions need to be performed. Okay, so right here, the data analysis part, data collection, and then data analysis part. That is where our big data comes into the picture. What's going on here, we'll observe in a moment. But before even going to the big data, we want to find out what are all the third-party softwares which can help these banks to come out with a prevention type of software, and then minimize the fraudulent activities, fraudulent transactions. I've been speaking to many bank IS auditors here in this meeting, and then I heard even some of these tools are already implemented. And then in case if you haven't, well, maybe it's time for you to get into this, because these softwares can really bring down all your fraudulent transactions that may go through online transactions or wire transactions, which are very dangerous because the money changes hands within seconds. And then also ACH automated check clearances. Look at the screen for a second and then just observe what are all the thoughts you can get. Okay, let's talk about it. First thing, login activity. Well, the device, maybe the machine, what the customer is using has been changed. Immediately, bank supposed to suspect, if not stop the transaction, suspect what is going on here. That could be a mobile or laptop or whatever it is. Why the device has changed? That is the first doubt we get. And then maybe the customer was unable to log in the first attempt. He is using 2-3 different passwords, guessing. That also another doubt that this software is supposed to understand this may be a abnormal activity, because according to my past experience in last 1 year, the customer was able to log in the first attempt. This is, we are now observing he took almost 3 times, giving wrong passwords and all that authentication problems. Well, another point to catch, where he is logging in from. In bank's history, this particular customer always used to log in from Queens, New York, but all of a sudden he found in Chicago today, and because we could observe his ISP, internet service provider, and then IP address, and the region has been changed. That doesn't mean that it could be a fraud, but yes, we have to get some thoughts on what is going on here. That's next thing, what he is doing. If I were to do some transactions for my electricity payment or municipal bill or whatever it is, I just log in. The very first thing I do, observe my bank balance and then go for the transaction. Where this guy is trying to, who has logged in using my credentials, somehow he got it using phishing, whatever, spoofing, all that stuff, and he is coming from another location, number 1, another machine, number 2, number 3, the very first thing he is doing, he is adding the payee. Well, that payee account is nothing but the fraudster's account, and that could be somewhere in some other country, not even in the US. And immediately bank supposed to doubt what is going on here. So in a traditional database environment, by the way, I've been working with Oracle since 1989, almost 26 years now. A traditional transaction which happens into the database can be logged only after the transaction is over. Whereas here, we are not even talking about the database, we are getting the logs from operating system level, network level, and then analyzing it. It is not even about a transaction. What exactly he is clicking on? He is clicking on, reset the password, or clicking on adding a payee. These are not going into the database. Only transaction goes into the database. So that is another doubt this third party software can catch it, what is going on. That is like during session. Well, across the sessions, last time, last few 20 transactions, whatever he did, there were not more than $100, but all of a sudden I could see $5,000 he is trying to transfer from one account to another account. And that payee also is a brand new payee. It was not a historical payee for this particular account. That again catches my eye. So multiple sessions. In the point number 3, we have discussed about one particular session. In here, yes, according to various sessions information, I derive that this particular transaction is abnormal. So maybe I have to decide whether the transaction should be continued or not, or whatever. This is the most important across the clients. Well, a fraudster who could somehow get into bank and get into a customer's account, transferred probably $50,000 from the real customer to the fake one, and then he found out the way to implement the same across different clients, and immediately bank got a call from the real customer that the balance came down 50,000, and then bank started analyzing what is going on here. So this $50,000 obviously is not a genuine transaction, it's a fraud thing. So, and then they understand the way the fraudster got into the accounts, and then immediately they must come out with another rule so that the fraudster cannot do the same misactivity with other accounts. That is called across the clients. I hope you are following the sequence 1 through 5. Anyway, at the end we'll have doubts session 2. So, but this is one bank in Mexico, and they came out with this report. Basically, in this section, they never had any kind of fraud management software. So obviously, they were not even detected, and when they were not detected, they cannot be recovered. That's a joke. And then they decided to implement whatever the third party software. We are not interested in the names, but they put some action in place, and since then, as you can observe, the number of frauds have come down, and then whatever happened, yes, at least they could recover it. So unrecovered also has tremendously come down, you know. So I'm sure here also banks have this kind of system in place. Otherwise, it's probably the time to look into this. So we are talking about not detected, recoveries, all that. Again, as I mentioned, we are visiting the same page again, and multiple sources. Users may be doing transactions from various different activities, and then we are trying to prevent, if not detect, and in case if it is detected, what is going on, how to go about it. So coming to the detection part, now we introduce big data. How big data can help banks in detecting fraud even before customers realize about it. Well, I'll just give you the names, have a second, and then try to remember the names. We'll be using the same names in the future slides. I'll just give you a couple of seconds. Please raise your hands. How many of you here are aware of HDFS? Okay, so I'll just go, very basic things on what's going on. Big data is a collection of data from various different sources. The source could be anything, including your social networking, maybe Twitter or Facebook or Google Plus, any source. 5 years ago, you might not even heard about big data, you probably haven't even heard, but all of a sudden, why it is there? Well, because if people are using it, no special answer. People started using different sources, and then that generated so many logs, so many pictures, so many videos, everything. And then now it's a time for us to collect all these things and make it part of our database, not actual Oracle database or Sybase or DB2 or SQL Server, but because they work with the traditional rows and columns kind of thing. But whereas here it could be anything, any type of data, log file, system logs, all that. So once you get into the data, yes, we have tools to analyze and come out. Simple example I'll offer you. One customer who is on vacation and he's in Hawaii and he is trying to do a transaction. Bank has no idea that this customer is out of station. But no, actually bank received one statement from Facebook that so-and-so customer said, I'm visiting Hawaii. And they could get this message into their database, and after analyzing it, yes, there is a transaction from Hawaii, it's a valid card, and because they already got the information, yes, they let the transaction go through. The better thing what should have done, the customer must update the bank about his travel plan, then this much activity need not actually take place. Just because customer never cared or maybe not even aware, or all of a sudden he decided. But thank God, yes, with the help of these social networking things, that could be Google Plus or Facebook or something, bank realized that he's in Hawaii, and they did not update him saying that is it you or not, because that could be another false positive, because banks always want to get down the false positives. So anyway, so we'll just get into these details in a moment. The catching term here is mining. How do I mine big data to bring it into action, to make it more useful? Okay, we always know data warehouses, but data warehousing concept works slightly differently. You know what you're looking for. Here you don't even know what you're looking for. You're just mining, and all of a sudden, yes, just like a gold mine, you got something out. There's a big difference between the real database, data warehouse, and data mining. And big data is all about data mining. Data is coming at a very fast pace that you cannot even imagine. Gigabytes are history. Now you're talking about terabytes or even petabytes. So much data is being generated through all these sites. That could be email or Facebook update, or could be Twitter or LinkedIn or whatever it is. Yes, finally the data is coming into your source at a high speed velocity. Volume is also big, so big. How do I handle it? My regular RDBMS cannot even dream of handling this kind of size. Whether you name it as Oracle or DB2, no database, a traditional database cannot expect this kind of volume or speed, and then store inside. And that's where the power of big data comes in. Variety means it is not like best example. I'll give you customer name, customer address, customer city, something like that. That is a regular data that you can always store into your normal database table. Whereas a email which has been sent by your loan applicant cannot be stored in the database. That email you probably store inside your big data. For what reason? Maybe for future analysis. In case if something happens tomorrow, you can always track what were all his emails, the transaction going on, all that, and then catch it. Variety of the data. Could be logs or real transactions, could be anything. Big elephant, I'm sure even in ICASA, I'll show you this here, this Hadoop. This is what we are discussing here. Hadoop has been invented for their own purposes in Yahoo. That was back in 2000. They never thought that would take the entire world to this stage. Why Hadoop? Well, Yahoo is known for search engine, just like Google. In fact, even prior to Google, Yahoo was there. And then they started researching and coming out, and good thing they made it available through Apache public licensing. I'm sure all of you know Apache, that's a public thing, everyone can use it and there is no cost associated with it. So Hadoop now became Apache Hadoop, and this is the symbol what Linux did in late 90s. Now Hadoop is going to do. Please be aware of this. And Linux has changed the industry face. All your other servers gone, including big Sun servers, IBM servers, HP servers. Now it's all about Linux servers. Same thing is going to happen now. Hadoop is going to take over. Next 10 years, it's going to rule the world. So why Hadoop? Like I said, it can store any kind of data, where a traditional RDBMS can store regular data, not any kind of data, but a transactional data. Documents you can store it in Hadoop, Excel documents, whatever it is. Hadoop is a combination of two things. One is like a file system storage, basically it stores the data. And number two, MapReduce is a process which can get the data out. What do you mean by MapReduce? As the term very clearly says, you are mapping the source and then reducing it, MapReduce, reducing it to the desired output. And this is what you actually want at the end of the day. So MapReduce is a concept Google has found. They made it as a white paper, and then with the combination of Hadoop and then MapReduce, yes, now the big data has taken a shape. Just storing data is of no use, and then without data there is no point in coming out with the MapReduce, but the combination. So whenever you talk about big data, there must be two components. One is Hadoop file system, and another one is big data. Sorry, another one is MapReduce. We'll come back to sorry about this. Yeah, distributed file system. No, not following what exactly distributed. It is not on one single server. It's actually the file system is using several different servers. How many? What do you mean by number of servers? Google has orchestrated 4,040 servers. You cannot even imagine this. 440 40 servers to support one file system with 8 petabytes of data. 4020 servers for one file system supporting 8 petabytes, and if that is your requirement, you have to have several machines. And great news about this, these servers are not expensive servers, not like Sun E250 or Sun Fires or something like that. They are commodity servers which you can very easily afford, and you are using Linux operating system, which is again completely free of cost. So that's how you are building multiple servers. It's a distributed server, and then again this is the most important thing, distributed file system. And availability. Availability in the sense, how about a server goes down? Not a problem, because the data being replicated onto another servers, so the complete data availability is already met. So don't even need to worry about that. Redundancy is the beauty about Hadoop file system, HDFS. As I mentioned you already, MapReduce is going to map the original source and reduces it through this computation, finally comes out with only the data what you really require. So whenever you talk about big data, it's a combination of these two things. These are the other tools. Just by storing the data, and MapReduce is a very complex tool that you have to hire a very senior high-end programmer to do that. So thank God Hadoop realized it, Apache realized it, and then they came out with additional tools to make the job simpler, to make the organizations implement in an easier way. And Pig is one tool where you can write a simple statement, and it also has a compiler that gets converted into MapReduce thing. So the names look very odd. What is that? Pig, Hive, and then Mahout and all that, but slowly you'll get used to it. What is going on? Pig is a simpler language, so that you don't have to write such a complex MapReduce program. So you simply come out with simple Pig and then let it go. Hive is more of a data warehousing thing, where you can even write SQL statements, normal select statements or insert statements or whatever, and then get the data from your HDFS, Hadoop file system. Okay, so this is the thing, SQL like language. And the last one is what banks are interested in, the Mahout, because this comes out with a recommendation engine. Please all of you concentrate here. Mahout is a tool, it's a machine thing, it can go through the machine data and come out with the data mining things, and can come back with, yes, these are the recommendations that Mahout is making to you. So banks, after storing the data, they are more interested in writing either Pig or Mahout statements. And sometimes if you have programmers, they can also use the Hive. But again, these three are very important, and they sit on top of Hadoop. Hadoop is combination of two things, HDFS number one, and number two, your MapReduce thing. I hope you got some idea on what is going on. So we have so far discussed 5 things, Hadoop file system, MapReduce, and number 3, Pig, Hive, and Mahout. Machine learning is very important. This is almost like artificial intelligence. It works like a brain, and you can submit your algorithms, your mathematical formulas. Banks can come out with the, yes, in such a case, what should I do, kind of thing, scenarios. Okay. I understood if I have the data, I can do so many things, but how do I get my data? Well, these are the tools. Scoop is a tool. You can use it to get the data from your traditional databases. That could be Oracle or Microsoft SQL Server or IBM DB2 or even MySQL. Relational databases. So Scoop is a tool which can extract the data and then load into big data. No, I'm not talking about regular RDBMS here. I have my data from social networking or system log files, network log files. In such a case, there is another tool provided by Apache which works like an ecosystem, Hadoop ecosystem, and that is Flu. Can you please raise your hands? How have you heard about Scoop here? I'm sure you must have heard, no? Okay. Okay, you did, okay, good. So these are the different tools. This all works like a combination. MapReduce, Hadoop file system, and then Pig, Hive, and all these work as a file system. Okay. Now we'll go back to our original diagram. Scoop is the one which loads data from where? From relational database into Hadoop file system. There is another tool, and by the way, this Scoop also works in a distributed environment. So in case if the data is very large, yes, you can have multiple servers loaded with the Scoop and then get the data loaded into Hadoop. Flume is like a raw data, completely log files, could be social networking sites. And then these two, basically they do loading the data, and then MapReduce is the processing thing. Either you can write your own MapReduce jobs, which is kind of difficult, hence you use either Mahout or Pig scriptings. No, I'm not following. What exactly going on? This has nothing to do with the bank. No. Once you get data loaded, we can come out with the decision makings. Okay. I know they are showing time up, but can I take 5 more minutes so that I can finish? Is that allowed or not allowed? Allowed? Okay, thank you. Thanks for supporting. So I have 2 things. One is the bank has its own data source, and another thing I can also purchase. Really, can we purchase data? Yes, sure you do. There are companies which sell the data from social networkings, and we'll pass on this information to you. You can decide in the you can see all these things. The green things are coming from external data sources. That could be system logs, web logs, Facebook, Twitter, and all that. And that you have actually purchased. It's a legitimate purchase. You are not downloading something which is free or something. Okay, I have some technology stack, and these are regular CRM, ERPs, could be geometric, and then Hadoop, and these are my traditional databases, Teradata, Oracle. Bottom line, yes, I'm going to use these reporting tools, Tableau, MicroStrategy, SAS, all that. And these tools are finally used by a power user of the bank, and this power user can come out with the decisions now and update the rules engine, so that at least next time they can stop the fraud to happen. So I hope you got this tools into your organization and also implement this. Okay, this is the last diagram. I'm not going to bore you more, and these are all our social networking slides, and then I'm going to use Flume to load into my HDFS MapReduce. My regular databases, Scoop is the tool, and then Pig and Mahout are coming out with analytics. My reporting tools finally come out with what is going on. I can even see geographical locations. Let's say in US, whether the transactions, fraudulent transactions, more in eastern region like New York, Connecticut, Boston, or the western regions like Los Angeles, all that stuff I can easily, pictorially I can see it. Okay. Did I say last one? Sorry. I have, this is the, these are the reporting tools, and I elaborated them for your information. Maybe we will share that with you. Well, are you ready? So please understand the power of big data and how to implement it and how your organization can be benefited.